if everybody is fine, so as Bihu hour, so will be the after the Bihu this video. So already we are in the topics that how to hide a line on the surface. Okay, there are some algorithms we have seen. One algorithm, the first algorithm we have seen, that is the painter's algorithm, where we have seen that how the object has to be drawn, and there the we have seen that one disadvantage. To overcome that disadvantage, we have seen again the next one more algorithm, that is called the Z buffer. Okay, so in the Z buffer again there we have seen that one disadvantage, that we will see that disadvantage is if one object is there. Okay, at first the depth of that object has to be calculated. Then if one more object is there, then again the depth of the another object also has to be calculated. After calculation, that the depth of that object which is more, that one will be the above, and the depth of the object which is less, that one will be the below. But here we have seen one disadvantage is that the above object is overlapping the below object. That means which part that below object is there, that object is not able to visible. Okay, for example, suppose this one we have already seen. Here we can see that here one polygon or any object P1 and P2. So the depth of this polygon, this P1 has calculated, the depth of that P2 has calculated, but it is observed that the P1 depth is more and P2 depth is less. That's what it is below and it is above 1. P1 is above 1. Now you see this part that overlapping, the red one is not visible. So this is a disadvantage of your Z buffer. Okay, to overcome this disadvantage, today we are going to see a new algorithm. That That algorithm is called that A buffer. Okay, so hope so you have got that what is the disadvantage of Z buffer. So that disadvantage will be overcome by the A buffer. Okay, so now as usual I have told that one. So these are the three polygon. So in that A Z buffer, what we have seen, suppose this green, if green has overlapped this blue, then the blue was not able to see, it was not transparent. But here you can see that in that example only I have shown that it is very clear how it is overcome, how it is transparent. Okay, so mainly in the same way as the Z buffer does, in the same way the A buffer also contain a two field. One is the depth field and one is the intensity field. So depth field is nothing but which store the number of pixels in the form of real, that is in the form of positive or negative real number. Okay, that is nothing but is called the depth field. And the intensity field is nothing but which contain a pointer value. So pointer, as everybody knows that what is that pointer, which takes the address of the another values. So in the sense what we can say, so intensity field, so this is a depth field is calculation of everyone, but intensity field is this one. Let's consider little bit here, you see. So this one is the intensity field, this one is the intensity. That means which contain this field, if I will consider this field or this field, these two field which contain the information of this green polygon as well as the information of this blue polygon and the information of this red polygon. Okay, so this is nothing but your intensity field which store the surface intensity information or a pointer values, which take the address, which take the values of the another polygon also. That is nothing but is called the intensity field. But as a whole, if you calculate, that is nothing but is called the depth field. Okay, so here we see. So that depth field can be greater than or equal to 0, or it can be less than or equal to 0. So it has observed that when a depth of one polygon will be calculated, after calculation, that as I have told, it can be a positive number or it can be a negative number. If the number of pixels, that means the depth of a polygon means the number of pixels, calculation of the number of pixels, which is calculated by 2 to the power n. If the number of pixels is greater than or equal to 0, so it indicates that that polygon has no overlapping. So in this three polygon, you see, so if you see this three polygon, so out of this three polygon, see this is the portion, this portion it has come here, yeah, this one and this one. So this is the portion which has not overlapped. So this polygon, this is the portion which has not overlap. So this is the polygon, this one is the portion which has not overlap. Okay, this one is the portion which has not overlap. So what they are saying that if the depth is greater than 0, that means that part of the polygon has not overlapping. There is a single surface overlapping. That one word has called single surface overlapping. In the sense, no other polygon has overlapped. Okay, if the depth is greater than 0. Okay, then one more condition can become that if it is less than 0, so it will be the opposite of this. So if it is less than 0 means what will happen means here the transparency, the intensity. So what is that? The intensity field and stores are pointers, which is nothing but, so in this polygon which is less than 0 means this part, this part, this part, this overlapping part, this is less than 0. Here again in this polygon and this polygon, this part, this overlapping part is less than 0. Okay, so it indicates that which contain a RGB intensity component, which indicate that red, green or blue intensity component, which contain a opacity parameters, opacity, because this is the major advantage of this A pointer algorithm. That is that, what is that? That opaque means the below what is there, that is transparent. Okay, the below one is also transparent. And the percentage of area coverage means how much number of bit has covered by this polygon. Okay, the above polygon is the green one, this green one and this blue one and the red one. So this above green one, how much percentage of blue polygon has covered, that one they are saying that percentage of area coverage. And again pointer to the next surface, the same thing only they are saying, pointer to the next surface. So I guess everybody has got that one. You have to remember two things. The depth can be greater than 0. If it is greater than 0, this is not a transparent, this is the whole one. If it is less than 0, this is the transparent part. They are asking the transparent part. Okay, so this much only there for today. So hope so it is clear to everyone. So why we are using this A buffer algorithm, so to overcome the problem of Z buffer algorithm. Please go through that video. If any doubt, do call me. Okay, thank you very much.